Let's look at our tutorial worksheet now. Now, Sabika, let me see. I saw you did your work. Heidi as well. Evan also. Jared, you have not done your worksheet, is it? Or you did it very late? Not done yet. Okay, too busy, huh? Is it because you have a lot of work in school? Okay, sure. No problem. So you answer now, okay? When we are going through the questions, you will answer accordingly. Heidi, are you here, Heidi? Your camera doesn't seem to be working. Okay, so respond to me. Good, thank you. Okay, now let's look at question 1. Okay, question 1, which of the following is a solution? Okay, these questions here can be tricky. Now, we had a similar question last week and we managed to understand what is required for this kind of question, right? If you look at first part here, talking about fresh apple juice, can you tell me, do you think fresh apple juice is actually a solution? Yes or no? No, right? Why is it not a solution? If you were to take a look, okay, I can show you a diagram later, okay, or a picture later. Now, when we talk about fresh apple juice, right, is those juice that we are squeezing freshly, okay, or blended freshly. If you take a look in my picture here, okay, are you able to see that there is actually some flesh of the apple inside? Okay, some parts of the flesh of the apples is actually inside. Maybe the skin is not there. Okay, but you can actually also identify after some time, okay, the top part will be clearer while the bottom part will be more cloudy. Okay, that is because the flesh settled down. If you are thinking about those that you are buying from the grocery store, okay, maybe on the airplane you are served some apple juice, it looks so clear, right? Those are not pure apple juice. Even if they say it's pure, right? Okay, it's because they have filtered away all the flesh inside this juice. Okay, and a lot of times they added something else also in order to make it look like it's a solution. But in its most natural state, it's not. This is actually stainless steel. No, sorry, this is actually steel. I wouldn't call it stainless because there are only iron and carbon inside. So steel is made of iron, and this is iron, this is carbon. Steel is an alloy. An alloy is also known as a solution. Okay, why is it called a solution? Can you see that whatever is inside steel, right? Okay, all these elements are actually evenly distributed throughout. Okay, evenly distributed throughout. Okay, so we call it homogeneous. And therefore, it is a solution. Now, in this particular example here, right, iron is actually existing in a higher percentage or proportion. So the solvent here is iron, and the solute is actually carbon. You need to take note of all this. All right, anything that is higher in terms of proportion, it is actually the solvent. Okay, in a lower proportion, we call them the solute. Right, so this is not evenly distributed throughout. You know, the flesh, most of it is at the bottom. Then very little at the top. We call this heterogeneous. Okay, and that's why this is actually a suspension. All right, yeah. So this is for apple juice and steel. So if we go back to this part here, coffee, then students start asking me, what about coffee? Okay, watch this video on coffee. Just 1 minute. It will take a while before the video appear. Okay, so you can see he actually put the coffee grounds in. He put in a whole container of very hot water. They soak for a while, so all the coffee flavor comes out. After that, he pours this through. This is the filter that is being used to remove the coffee grounds from the coffee that is made. Yep, so this is also called the socks, coffee socks. It acts as a filter. So this is how it's done. The coffee grounds are not soluble in water, which is why in our question here, right, when it refers to the coffee, you cannot think of coffee over here as those 3-in-1 or those that will dissolve immediately in water. Those are processed coffee. Clear? It's already made that way. So how do they form that kind of 3-in-1? They actually make the coffee first. Yep. Then after that, they dry that coffee drink, okay, into powder form. So that's why you have your instant coffee. Then, of course, they add in, the creamer and the sugar to make your 3-in-1. So this is the correct way, the original way of making coffee in the past. Now, modern days, we have a lot of new ideas coming out. Okay, so when they ask you this kind of question, right, you are really referring to the original, the most natural state of the coffee, most natural state of the apple juice. Okay, so that's why this is a suspension. Okay, so for those of you who have question about this, because you go and Google, right, you will see that apple juice is solution. Is not. Okay, this is solution, this is suspension, as we have seen just now. Mud, definitely it is suspension. We already know. Okay, yeah. So our answer here is B. Correct? You all got B, right? Good. Let's see. Yeah. So if you have not gotten it correct, I think you can understand this now. Okay, question 2. Which of the following factors affect the solubility of a substance? Now, if you remember, we talked about solubility last lesson also. Factors that affect solubility of a solute in a solvent, okay, is about the nature of the solute. What are we trying to dissolve? Sugar definitely can dissolve easily in water. If I want to dissolve sugar in oil, it might not be that easy, right? So the choice of the solute is important. The choice of the solvent is also important. So you must make sure whatever solute and solvent that you're choosing, they must be compatible, okay, such that the solute can dissolve in the chosen solvent. Is that all right? Then you can get the solution that you want. Yep. Then you can talk about, this solute is soluble in a solvent. Okay, however, if let's say I choose this particular solute and then, I made a choice on the wrong solvent, definitely solubility will be very low or even 0. Okay, another one will be the temperature of the solution. Okay, like dissolving sugar in ice water compared to hot water is going to change the solubility. All right, so these 3 factors here will affect solubility. Solubility means how much can be dissolved, okay? So you can have even 0, you can have 10 gram, you can have 20 gram, it really depends. Size of particles only affects the rate of dissolving. Okay, so there's a difference between solubility and the rate of dissolving. Okay, this is about how much can dissolve. If a lot can be dissolved, means it is very soluble. If very little can dissolve, it is not so soluble. Then when we talk about rate, is how fast something can dissolve. All right? Okay, so this is about how fast or how slow. Okay, there's a difference between the two, so you need to know. In this particular tutorial, do you notice that they ask questions about rate of solution or rate of solubility, I mean? Okay, so rate of dissolving versus rate of solubility, are they the same? Yes, they are the same thing. Okay, they mean the same thing. Okay, so always about how fast something dissolves. So if you see rate of solubility, they are trying to ask you rate of dissolving. Okay, so already we have our answer here, right? Okay, nature of the solvent. Nature of solvent means type of solvent. Temperature. Okay, so is this 2? Definitely your answer is A. Any question here? If you confuse yourself between the rate, okay, versus solubility, then you will choose the wrong answer. Okay, yeah. So when you choose 1, 2, 3, I know you have not understood what is the difference between solubility as well as the rate of solubility. Okay, Savika, you now understand? Good. Paint can be dissolved completely by turpentine, but not water. Okay, so it can be dissolved by turpentine, not water. Remember, we talked about painting. Okay, the painters will have, some paint on their hand, on their face, with their hand. So they need to remove that before they travel home, right? Otherwise, people will look at them with all this paint on the body. Okay, it can be a bit awkward lah. Okay, so when they remove, they don't use water. It's not possible to remove with water. They will use this turpentine. It's a very strong smelling liquid. Okay, but it is so good at removing the paint. They will take a rag. They will then, put the rag over the mouth of the bottle, turn it over, pour out a little bit. Then they just clean off like that very easily. Okay, so that's how it's done. Now, you are supposed to find out the statement that is not true. Okay, so this information here, does it say that the type of solvent affects solubility of the paint? Yes, it is true. So if I choose the wrong solvent, of course, the paint cannot be dissolved. Right not? So solubility of paint in water is 0, but solubility of paint in turpentine is very, very high. Okay, so this is a correct statement. Turpentine is the only solvent that can dissolve paint. Is it true? Actually, it's not true. Some of you might think that this is true. All right, but in this question, they are only comparing between 2 solvents, water and turpentine. How are you so sure that paint cannot dissolve in something else? Okay, there's actually something else which maybe the girls will be familiar with. Okay, it's called acetone. Acetone can dissolve some of these paint. All right, maybe not as good as the turpentine, but acetone can. Okay, what do I mean by acetone? It is found inside nail polish remover. How many of you paint your nails? Evan, do you paint your nails? No, right? Yeah. I do, okay, when I was younger. So I use those nail polish and I clean off using the acetone, which is the nail polish remover. Okay, nowadays they have something newer. It's actually dried by the UV. So Heidi, have you painted your nails before? How about Sabika? So are you familiar with the nail polish remover? Heidi never paint before. Okay. Savika, maybe you did, right? I'm sure you did. You never? Oh, when I was your age, I already painted like maybe 100 times already. Since young, primary school, I very vain one, I'll ask my mom to paint my nails, paint my toenails, paint my fingernails. Yeah. Okay, good girl. So you don't, yeah. Okay. Anyway, so if you try, it can actually remove. So we can't say that definitely there's only one solvent. Okay, not true. Now, no residue is observed in filtration after paint is placed in turpentine. Yes, it is a correct statement. Remember, solute. So the solute here is paint. The solvent here is turpentine. Okay, and then the solution, I don't know what's the name. Maybe it's a paint turpentine solution. All right, so because it dissolves so well in turpentine, right, it forms a solution. It is not going to have anything trapped in the filter paper. We did filtration last week, correct? So you're not going to see any residue in the filter paper. So this is a correct statement. Stirring the paint in turpentine decreases the time taken for the paint to dissolve completely. Now, stirring always actually help the solute to dissolve faster. So when it helps the solute to dissolve faster, you are decreasing the time, right not? So this is a correct statement also. So only B is wrong. Okay, only B is wrong. We can't be so sure it's the only solvent. Yeah. So this is the answer. Let's go to question 4. Which of the following statements is not true? Okay, so we look at some notes first.